All right.
Okay. I just muted and unmuted again and it did something. Bad contacts, I guess. I'll spray it with something.
WD-40.
All right, Mario, you can share your screen whenever you're ready.
All right, let's try that out. All right, can you see that?
Yep.
Oh, yeah.
All right, good. So I thought I'd just give some highlights over the past few months. I don't have a specific theme of any particular object other than to introduce the object of the month. A gentleman by the name of Roger Ivester from North Carolina has been doing this for over 10 years now and has gotten quite a following. He started with the Las Vegas group and then it's been spread to quite a number of clubs around the country. The ATMs, which I belonged to since 1968, Boston, have kind of taken it on, and quite a number of people try to take images that he suggests. And it's gotten to be rather interesting. What I like about it is everyone takes pictures of it or does a drawing or describes what they see, and it's all in one place. And in one spot, you can compare different techniques, can compare observing styles, different telescopes, different resolutions, and all about the same object. He's got over 200 objects now in his database. And I've been doing this now for a couple of years for him, and it's kind of interesting. So I'll show some of the objects of the month, and from going forward, I'll show you a picture of the object of the month. I think Barry and a few others said they were going to try to get pictures as well, right?
Yeah, for February, and mine made it in for January.
Great. So more the merrier, and we can compare different styles, different telescopes, different exposures, different filters, which I think is a nice comparison. So anyways, the first picture is not my picture. This was taken by Babak Tafreshi. You all remember him, and he's an incredible nighttime photographer. I think probably one of the best in the world. He does the World at Night website along with people around the world. Came from Iran originally. He actually took this a few years ago and then never processed it and realized he hadn't and sent it to me in the fall. I now printed it out and have it hanging up. I just love it. It's a nice picture of my observatory and house with the sky above it. Judging from the trail, that's probably about a 1 hour or just slightly less than that, 40-minute exposure. And he always gets the most out of every photograph. But I just use it to highlight what we have here in Gloucester and why we need to work to protect the sky. I don't think you can get a picture like this anywhere in Eastern Massachusetts anymore, except maybe the Outer Cape, and that's about it. So we got to protect what we have. I think it's a great resource. Let me see how this, okay. So, to recap the last few months over the summer, we'll all remember Comet Neowise. Here's a picture from my deck looking north across Ipswich Bay to those lights and horizon are New Hampshire and the Seabrook Power Station. But just to give you a scale, but it was a great comet. And here's more of a close-up that I took. It's a great comet that had a nice ion tail and a beautiful dust tail. Just so people know, the ion tail is mostly carbon monoxide. That's why it glows in that color, brilliant blue. And it's always exactly 180 degrees away from the sun. So if you follow the ion tail, you know where the sun is. The dust tail, which is yellow and curves, is more where the comet has been moving from, and that it depends on where the comet's been and where it's going. But that's mostly dust reflected, and the blue is the ion tail. Let's hope we have another nice comet this year. So the September object, I won't go through all of them, but the September object happened to be the Veil this year. Oh, by the way, anyone know Sue French? She gave that. Yeah, she wrote those articles in Sky and Tel for many years. She retired from Sky and Tel this past year, but she's also part of this. So in addition to Roger cataloging all these observations, Sue will write a summary and like she did for Sky and Telescope about every object every month. And that alone is worth it. But anyways, this is the Veil Nebula. And this is the three main parts of it. Now, this is not with my 32 inch, it's with my 6-inch refractor, or you wouldn't be able to get such a wide field. But I used the 3 narrowband filters in each section and did a composite of all 3 sections. The real Veil Nebula is about 15,000 light years away. It exploded somewhere, I think around several thousand years ago, and it covers about 3 degrees of sky. And what you get is different arc sections of the shock wave. Looking at the one on the left, which is the easternmost side of the veil, you can see thin red line, which is a shock wave, and then all these different lines are different shock waves. And what it is expanding gas moving at hypervelocity with the particles banging into cool gas. You don't really notice it on this photo, but there are fewer stars on the left and the right because of dark gas. But because the long exposure doesn't show up that well, that effect doesn't show up as well. But it's being lit up not by radiation from stars, but rather by the shock front itself, exciting the cool gas into a hot gas. And then when it recombines, you get an emission. The red is hydrogen, the yellow is sulfur, and the blue is oxygen. And the same for all 3 across. But it's a great object for those that have looked at it, know what I mean. Use an O3 filter on it, and it's a beautiful object to look at in the summer skies. All right, so then M76 was the December object of the month, and hadn't taken that in quite a while. Old photo I had was like 10 years ago, so I said it was probably worthwhile getting another one. I'm glad I did. I did it in narrowband filters, and what's interesting about the M76, called a little dumbbell, but it has 2 distinct cavities if you look at it. And the reason, it turns out, is it's felt that it's a bipolar nebula with, that was created with 2 separate stars, a binary star. One went nova and then the other one shed its gas. So it's probably created by 2 stars in orbit and 2 white dwarfs now in orbit around each other, creating this unusual shape, which is kind of interesting to think about when you look at it. Next is NGC 1893 and also IC 410. So the cluster is the NGC. That's easy to see through a telescope, even a small one. The IC 410, it refers to the nebula. Now this is through my big scope. I purposely zoomed in to get away from the bright star that's next to it so it doesn't overexpose everything else. In fact, I wouldn't be able to get this picture with my old CCD camera. The newer cameras with no longer bleed like the old ones, and I'm able to get pictures next to bright stars that I couldn't do before. So there's something to be said for CMOS on that regard alone. But this is, see, I'm sorry, I went ahead of myself. This is IC 348. I jumped ahead. This is IC 348, but this was discovered by Ed Barnard when he was looking for dark nebula. He came across this one, what's interesting about this one is that it has 2 designations. It's IC 348 and also IC 1985. And the reason for that is Safford discovered it a few years before, and it wasn't noticed that it was a double designation. It's 1,000 light years away, and the star cluster is about 2 million years old. Now, this is what was behind my head. This is the object of the month for this month. This is NGC 1893, the star cluster in the middle, and IC 410. This is an Auriga. It's a larger object. I went in with my larger scope because I wanted to zoom into the tadpoles. And you can see the tadpoles on the left, the dark nebula in the middle, and the bluish diffuse nebula behind. And what that is a new star cluster. It's 3 or 4 million years old, an open star cluster with about 50 stars in the cluster. And it's the ultraviolet radiation from new stars is lighting up the gas behind it, which is why you got all that blue. There must have been supernovas because blue, with the blue filter, yeah, it's not a blue filter, it's the oxygen filter, it shines blue. So there's a lot of oxygen there, which usually implies supernova explosions. The two tadpoles on the left are Bach globules that are being lit up by the radiation from the stars, and they're being radiated away. It's kind of like the pillars of creation, except they're more lit up. It's got yellow, so it's got sulfur in it, but it's and it's got new. And the head of the lower one on the left has those two stars to the right. Those are actually in the nebula, and they're new stars being born from this Bach globule, which is kind of interesting. Go next. Oh, by the way, for those who can do wide field, like Barry, this would be a great object to take. And I think you did it, because it's much bigger than what I'm showing here. Right next to it, since I was right there, I decided to go for another one, is IC 405, which is the Flaming Star Nebula. And this is part of the same extended gas cloud that forms the tadpoles in 410. As you can tell by the numbers, are real close to each other. The flaming star is basically a real bright star, and when you look at it visually, some of that gas looks like it's smoke coming off the star. I guess that's why it got named that. In a photograph, of course, it's a nebula with a bright star next to it, and the star is lightening up the nebula. Again, this is another one I could never take before with a CCD camera, because that bright star would bleed mercilessly and ruin the photograph. But with the CMOS, they don't bleed. They kind of just, they may bloat a little bit, but they don't bleed. So I'm kind of pleased that I can get some photos I could never do before with the CMOS camera. You all know what this is. I retook it from my photo that I've taken of this years back. And the reason is I wanted to try with multi-filter, but I think the H alpha gives you the most detail. So if you look at, this is just the hydrogen alpha frame of it, and you can really see nice detail within the body of the neck of the horse there that I hadn't seen before with my older photographs. There's quite a bit of detail. There's stars embedded in it. H alpha goes in the red. And I'm just pleased with the amount of detail. And then if you look at the what looks like billows clouds behind it, that's all lit up by a star up above the frame. That's above the frame of that's lighting up this cavity of gas. And what we're seeing here is just an extension of the dark gas sticking out in front of this cavity. And that's why we can see it, because it's a dark nebula. Now, this is the same photo with the H alpha, but combined with sulfur, of which there was very little, and with oxygen, which was practically non-existent, but it gives balance to the color of the stars, and also red, green, and blue. I kind of went for broke. I wanted to see what I could do if I try all 6 filters and stack them. I still think the H alpha alone gives you the most detail, although visually combining all 6 filters together gives a nice pleasing color image. But again, it's something you've all looked at, H alpha. If you have an H beta filter, you can see it visually, even through the 32. You kind of need the H beta filter in order to see the dark nebula. All right, now just east, immediately east, if you go back, look down, because this is rotated. North in this picture is on the left, rotated to make it look like the horse head. So down, which is east, you have this, which is NGC 2023, which is completely overlooked by most people. In fact, if you look to the right, you see a little bit of yellow. That's a bit of the bright nebula that shows off the horse head way to the right. So NGC 2023 is a poor, overlooked nebula. I thought I'd give it some prominence. It's basically a new star being born inside this dark nebula. If you think of the Trifid, where you got several new stars blowing out a cavity, well, here you got a new star embedded in the gas that's going to slowly make a cavity inside this dark gas, which is all surrounding it, which is kind of neat. So you see a new star formation and a new cavity being born here. It's very small. You need a kind of a large telescope to see this one. And it's frequently overlooked because people look for the horse head and ignore this. So I'd give it some prominence. Okay, this is something I came across when I was doing the veil, not the veil, I forget which, I was photographing something, and I noticed on the star catalog, there was something called the tick right next to it. It turned out it's incredibly faint. Don't bother looking for it. You're never, ever, ever going to see it. Even through the 32, I cannot see this object. This is a like 3.5 hour exposure in just H alpha. It took that long just to get anything. And the individual frames, you barely notice anything. But it just happens to be a gas cloud lit up faintly by a couple of stars in the center of this. And it happens to look like a tick. So it's called a tick nebula. It's also known as the flea nebula. I think it looks more like a tick, but going back to when Phil showed all these different animals on his presentation a year or two ago, he can add this one to his list of eye animals. I retook 891 because I wanted a better photo than I had before. And this was my attempt. I went deeper in this. I think it's 2.5 hours to try to get more detail in that central dust lane. I think the NGC 891, which is northeast Andromeda constellation, is the second best edge-on galaxy in the sky. Not the only thing that beats it is 4565 in Ursa Major. But this is a beautiful edge-on galaxy. I'm sure some of you have seen it, and there's incredible detail within the dust cloud, the dark lanes within this galaxy. It's 27 million light years away. You can see some faint galaxies in the distance beyond it. It's a really nice galaxy to look at. Okay, this one is the object.
Mario, what's the designation again of that previous edge on?
This one?
Yeah.
891, NGC 891.
Okay.
Beautiful galaxy.
I may do it next year when it's available.
Great. In the fall.
In the fall. Okay.
Yeah, it's in Andromeda.
Mm-hmm.
Okay, this is the object of the month for March. I took it already. It's a polar galaxy. This is NGC 2685. It's in Ursa Major. I stayed up late early in January to get it because I kind of knew February was not going to be good. So, anyways, what a polar galaxy is, I don't know if you can notice it, but there's a galaxy edge on looking at us, and then there's a galaxy at right angles that this is spearing right through. And you can see this faint line of a spiral arm in blue. And the reason it's in blue is because it's a Seyfert galaxy. It's a star-bursting galaxy. So there's a lot of new stars being born, probably because of the merging of these two galaxies. It'll eventually turn into an elliptical galaxy, but we're catching it in the merging phase. This one's kind of difficult. Visually, you'll see the central part. You won't see the spiral arm that's at right angles. It's just too faint. I took this in red, green, and blue in order to get this. Can't use narrowband filters on galaxies, but it's it's 42 million light years away, and it's one of the few polar galaxies like this. I'm going to show you another example that's in Hydra. This one is 3178. I'm sorry, this one is 660. I have another one. NGC 660. This also a polar galaxy. This is in Pisces, and this is 45 million light years away. But this one shows the polar galaxy structure, I think, a lot better than the object of the month for March. I think everyone can see that you got one spiral kind of edge on, you got another spiral edge on, but they're at right angles to each other. Can everyone appreciate that? This is one of my favorite photographs, just because I think this is the best example of a polar galaxy in the sky. And this one, Barry, if you really want to chase something, this is it. Next fall, I plan on doing this one in colors, since the other one I did in color, just because I know the thin spiral arm is intensely blue. It's also star formation. Plus, it's got a lot of neat, faint, distant galaxies in this field of view, so it's worth chasing. This is the other one, N3178 in Hydra, which is also a polar galaxy. So I just showed you the three best polar galaxies in the sky. And this one is in Hydra, and you can see again, a spiral galaxy at right angles to the other one. And the spiral arms on the main galaxy have been pulled out because of the gravitational interaction. What's interesting about this is you got that interacting group way in the distance. This one's about 50 million light years away, roughly. The one below is something like 160 million light years away. And it's 4 galaxies interacting, and there's a 5th one on the left that's, I don't think is part of that group. But it's just a great field. I should do this one in color as well. All right, so next is, as you know, I like barred galaxies, barred spirals, and I took this in November, I think it was. Anyways, this is in Fornax. It's NGC 1398. And what really intrigued me about this is, and you can see this, it has a double ring. So you got a central core, a bar which is vertical here, top bottom, a inner ring with this intense star formation. It's professional, it's blue. And then you got some spiral structure, and then you got an outer ring, and then you got a flocculent galaxy on the outside. So it's got just about features. It's kind of a mongrel galaxy with features of multiple different galaxies in it. And I'm going to have Bill give us a lecture on how something like this can form someday, because I don't understand it. But you got to admit, Bill, this is rather interesting. I'm fascinated by this galaxy because it's got so many individual features in it. And NGC 7217 is also a inner ring and an outer ring with an outer flocculent. So I'm trying to pick, I have, in case you hadn't noticed, I like unusual galaxies. The ARP list is my favorite list, and galaxies are my favorite things to image. But the unusual galaxies are really, ARP was correct. Finding the unusual galaxies, it's kind of like in medicine. If you want to learn about a human anatomy and normal structure, you study the diseases, and what goes wrong tells you what that function was. So if you have a stroke in a certain part of the brain, you know what that part of the brain was supposed to do. It's kind of like galaxies. If you find the odd ones, you hopefully can figure out evolution of galaxies and how they form and how they evolve. I hope I'm saying that right, Bill. So just got a couple more here. This is NGC 7727 in Aquarius. This was in the fall as well. And it's also the merger of 2 spirals. But instead of being a polar galaxy, these kind of squashed on top of each other, and the spiral arm of one of them spread out. but they're merging face to face, unlike the other ones, which were polar. And finally, if we're going to let go of the season, a little farewell to the planets. Here's Mars back in October with Sirius Major. Here is Jupiter. Forget when I took this one. I think it was in October as well. And that's Io, way out in front of the planet, just off the edge there, and shadow of Io on right there. I suppose I should have been using my pointer, the shadow of Io, and you got the great red spot over here. And here's Saturn from September. Just a nice image. Probably the best one I've taken is Saturn. Beautiful image of the rings with the, anyways. And finally, I'll end with the sun, because after a 3-year hiatus, the sun finally has woken up and we're in the new solar cycle. It has an 11-year cycle and we're at the beginning of the next one finally. You can see a sunspot. You can see the magnetic field distortion around it, another sunspot here. A couple of prominences are nice in this picture. This is the exact same view, except through my 6-inch scope with a white filter. And so you can see those two sunspots. So go back and forth, it's the exact same thing. And this is a close-up of that same sunspot group when it moved further over to the sun a week later. Okay, so I'm done. Let me stop sharing. And I suppose we should probably do questions later. I'll turn it back to you.
All right, thanks. Yeah, let's do questions after everybody's gone. That'll keep the schedule sort of on track, at least for GAAC. Listen, I'm getting notices all over the place about an unstable internet connection. So I think if you can't hear me and all of a sudden my connection goes bluey, I think you guys can share and do your presentations without my help. So if I start going like this, just carry on, okay? So next up, Phil, you're up next.
Okay, so I press share screen to get started, right?
Well, yeah, get your PowerPoint going first and then share screen, and you pick up on the PowerPoint when it gives you the menu of what you want.
Really, I do the PowerPoint before I share screen?
That's correct.
Okay. Well, I don't think that's correct.
Shrink the PowerPoint down to an icon in the lower tray. There you go.
Okay, can everybody see this?
Yes.
Okay, so we're in business?
Yes, we are.
All right, let me continue then. So the theme for my presentation is called Striving for the Best Image. And the reason for this is because of circumstance. I had to do something other than show new pictures because in early October, my whole telescope system went down because of this logic board in my mount. And it turned out it was just one small part that was the culprit. However, the maker of this board was suffering due to COVID restrictions, and the maker of the mount could not get me a replacement for almost 4 months. So I was out of business in my observatory until early January. And as a result, what I decided to do was to show how over a course of years, I was able to refine and improve 4 very well-known images with photos that I had previously taken, with one exception, and that is after I got my logic board back, I wanted an easy subject that I could use to get my telescope back to 100%. And so I chose the Great Orion Nebula, and I finished that off. So everything that you see in the presentation tonight was taken with one 14-inch reflector or another over the period of time, except where noted. So we're going to start with M42, the Great Orion Nebula. And this is my very first astrophoto. I took this in November of 1987 using a Celestron telescope with a clock drive. an SLR camera. Notice I didn't say digital single lens reflex because they were a dream for the future. And I had to hand guide this. We all did, for those of us who were trying back then, using an off-axis guider. And I think this was 45, well, it says 45 seconds in my notes here, using 2000 speed film. So it's a single image, 45-second exposure. After a couple of years of trying astrophotography back then, I decided that it was just too much effort. And then I entered a very long period of time where I was away from amateur astronomy. And I finally got going again in 2012 when I took this picture. Now, this time I had a Celestron camera that attached to my laptop. I had a digital single lens reflex camera, and I was just starting to learn how to perfect, or not perfect, but how even to take a picture and then to process it. So this is 2012. Now, the following year on the left is an image that I took, which is starting to look a little bit more respectable. But the great problem with Orion is that the contrast between the darkest portions and the brightest portion is so immense that you typically blow out the center. The center just becomes overexposed. However, about the same time, I learned of a technique that terrestrial photographers use to eliminate glare. It's called HDR, or high dynamic range. And I took the same photograph according to the requirements for HDR, and I was actually able to eliminate the glare in the center so you could see the core and even get an idea of the trapezium, which is the 4 stars clustered together that causes this immense glare. By 2007, I had a CCD camera. 2017, I had a very good 14-inch telescope. I had a pretty good grip on how to process. And now I decided to take 8.5 hours of Orion and the Orion Nebula. And you can start to see a lot more of the nebula, although the detail is not particularly sharp. So then I added to this image, and here we are now 10 more hours into it. We're up to 18 hours. You can start to see some really good detail in the outer part of the nebula, but it's obvious to me, at least, that I'm leaving a lot behind. I'm not picking up the detail in the perimeter, and by no means am I picking up the faint background red nebula that Orion sits on top of. So when my logic board came back and I went back to work, I took 18 more hours of Orion, and this is what I got. So this, as far as I'm concerned, is probably as good as my telescope is capable of resolving. You can see the red nebula in the background, which was always a goal of mine. And not only that, but when you look down now, it becomes almost three-dimensional, and you can see into what appears to me to be like the cone of a volcano. Orion is just absolutely roiling, and the outside of the cone, if you will, is in motion. All of these filaments or gas that are really being blown by cosmic winds. The center is very well resolved. Here's the trapezium, you can make it out there. And these darker areas are, as Mario pointed out about the tadpoles, these are Bok globules where new solar systems are being formed. Now, I'm going to show two more takes on this, but before I change this photo, just look at this area right here, because I'm going to show you a close-up of it soon. So here's a picture from several years before taken with my refractor that really shows off the hydrogen alpha nebula behind both the Orion Nebula and the Running Man. And then finally, to wrap up Orion, here's a close-up just to give you an idea of just how much is going on in just one corner of this nebula. So anyways, I'm done with M42. It's just, I don't think I can improve on this at this point. Extra hours are not going to get me more detail. So now we're going to go on to the double galaxy in the Big Bear, Ursa Major, M81, M82. So my first photo of this back in 2013, it's almost cartoonish. I've got the colors bloated, they're wrong. Um, yes, I did pick up detail in both galaxies, but it's just really an awful photo. Following year, I went back and tried it again, and the color balance is better, but the image is fuzzy. I didn't have enough time in it, and that's why the detail is lacking. So I go back in, but I wanted to point out before I go on that that same year, let me just go back here for a second. That same year, a supernova appeared in M82. And here's a close-up of M82 before the nova, and here's the supernova. I wish I knew then what I know now, because this photo would have been a lot better, but at least I did get the supernova. So in 2015, I tried again, up to 3 hours. The image is somewhat sharper, but what I found is it's very difficult to get rid of the muddiness in the core of M81. I'm not sure why that's true, but I really struggled trying to get proper color balance in this galaxy. And when I tried the following year, maybe it was a little bit better, but it's still not right. And then I took a step backward in 17 when I made a mistake with my filters, and I got this really garish looking M81 here, although M82 for some reason is looking better. So finally, I settled down the next year, put a lot of hours, 26, into retaking it. And now it's starting to look presentable. M81 has got, M82, I meant to say at the top here, is starting to look appropriately colored. And even here, I'm starting to tone down the muddiness in M81. And you can start to see this little dwarf galaxy, or Holmberg 9, which is a companion of M81.
How many images, subs?
This is 26 hours, and each sub is 4 minutes long, so 15 times 26. And it's in 4 colors, Barry. It's blue, green, red, and H alpha.
Okay.
Okay. So now, finally, in last year, I finished it off. It took me 40 hours to get it right, but let me just go back just for a second. You can see this muddiness is, whoops, sorry. This muddiness is finally gone. I've got correct colors for M81. You can see a lot of detail in the spiral arms. They're nicely feathered. You can see a lot of nebulae in the arms. Now, the starburst red streaks, and this is a close-up, in M82 are caused by the close encounter it had with M81 20 million years ago. This is actually a spiral galaxy that has been really bullied, if you will, by M81 during that close pass. But the most notable result of the close pass is this terrific starburst activity that's taking place or at the core of M82. And to give you an idea of just how high these columns extend, if this was at the core of the Milky Way and the solar system was right about here where I'm pointing with my pointer, these plumes of red hydrogen gas would extend from Sagittarius to north of Cepheus. So it literally in the summertime, if you were able to see these comparable cones in the Milky Way, they would almost entirely cover one portion of the sky. So now we go on to the Great Andromeda Galaxy, which is a favorite, of course, of all amateur astronomers. And the first time I tried to photograph it back in 2012, I didn't even use a telescope. I simply used my camera with a 200mm lens for 10 minutes, and I got this washed out image. I mean, the only thing you can say good about it is Andromeda. Then the following year, I spent an hour on it, and with a telescope, a small refractor. And I was able to show that it is multicolor, but again, its resolution is not particularly good, and there's no detail in the center. But by 2017, I invested 16 hours. I had a CCD camera by this point. And let me just point one thing out. One of the banes of astrophotography is that stars tend to dominate the image that you're trying to feature. And you can see here the stars they're prevalent and they're fairly large in size. However, fortunately, software permits you to diminish the size of the stars. So here you can see just as many stars as in the prior photo, but because they're smaller, the galaxy is easier to see and your eye more naturally rests on it. So here there's a lot of detail. It's not as complete a image as it should be. I'm not really getting a lot of the perimeter, but it's 16 hours and that's a starting point. So I added hours to it in 2018. I came up to 24 hours and I'm getting more of the perimeter, but it's just doesn't look right. So I tried again with 32 hours, added another 8 to it in 2019, and now it's starting to look delicate. This is pretty much what you would expect from a galaxy where the edges would feather into space because there's just less material out here. And finally, I finished it off last year. It took me 42 hours before I was finally happy with it. And this has everything that I was looking for. You can clearly see that this dwarf galaxy M110 is actually embedded inside of M31, which means that over time, the gravity of M31 is just going to pull this apart and the stars will dissipate and it will just become blended in with the mother galaxy, if you will. And even M32 here, you can notice that there's a trail of stars that are being vacuumed off of it by the gravity of M31. And as I mentioned, the outside is nice and feathered and there's a plethora of red nebula that you can see here, and a lot of detail even in the darker areas. So anyways, I'm done with M31. Finally, we get to the Great Hercules globular cluster. And pardon this, how awful this photo is, but this is my first picture of it back in 1988. Again, hand-guided with 2000 speed film in 45 seconds, but I did not do a good job hand guiding this image. And you can see that the stars look like trails. Well, the last thing you want to do when taking a picture of a globular cluster is to have star trails because it's just going to wash out and become mashed potatoes. And that's what I got here. So one of the first objects that I tried after I got my new telescope and a DSLR camera was M13, which I only took 7 minutes worth of pictures, and there's not much to say about this. But in 2014, with a new refractor, I took it again, and thanks to the fact that software now, Astro software incorporated that high dynamic range technique, I was able to resolve the core, but the colors are all wrong. And well, it's a step in the right direction, but it's not there. I tried it again in 2016 with a lot more hours. The colors are still wrong. It's greenish. That's just a no-no. But finally, in the next photo, I get it right. And this is 25 hours, which I took last year. And now the colors are properly balanced. The core is resolved. I'm not going to take time here, but Mario has pointed out there's lots of little tiny galaxies that you can see around the perimeter of M13 looking through the stars in its outer reaches. I'm told, by the way, that as dense as this ball of stars is, that if you were on a spaceship, the chances are pretty good you could fly right through. Oops, sorry, I didn't mean to do that. You could fly right through it without crashing into a star. So to conclude, this is the 5 images that I ended up with, which I'm now saying are final. So that is it. Thank you very much.
Okay, my turn. Michael, I'm up.
You're third, Barry.
Okay. One second. Share screen 2. Oh, gotta start the show. Come on, 1 second. chair.
Bill, I don't know if anyone else who has the patience you do, multi-year imaging.
Well, it's the only way I can get them to look as good as I hope they could look, Mario.
Yeah,
That's the payoff.
I've never done multi-year, but I have done multi-day.
Yeah.
Like Phil, I wanted to do a few things differently. I've spent a lot of time this year actually redoing my Messier catalog. The first one that was posted to the GAAC website was back in, I think, 2017 or 2018. And then with the newer equipment, I started going back and redoing some of the old favorites. So if anybody wants to take a look at my Messier catalog, it's up in the gallery. Instead of going with 9 per frame, I did 4 per frame, just to show a little bit more detail. And I think part of it is also attributable to the, as Mario said, these CMOS cameras are amazing. And I'm going to point out a few things. But my topic is then and now. And the reason I jumped into this about 3 weeks ago, thought about it, because we've been doing the basement cleanup, and I came across a book. I have no idea where it came from. It's called The Nature of the Universe by Fred Hoyle, and it was 1950, and that it was published. And in the middle, there were a number of astrophotographs of some of the objects that I've taken. So I'm going to start off with about 5 photographs showing some of these amazing photographs, probably circa sometime in the 1940s. And then I'll get into a few others that I've done in recent months. So without further ado, can everybody see my, and can you see my pointer?
Yep.
Okay.
Yep. You're good.
Okay, let me move this over here. And so, let's see. There we go. Just a recap, Mario had mentioned that my specialty is in wide field. I've got the Rowe Ackerman Schmidt 11-inch. You could see the street light in the background. People have their lights on. So I have to go with I end up with a lot of local noise. There is a dew shield, but I want to show that fact that the camera is is where the secondary normally would go in a Schmidt Cassegrain. Is not a Schmidt Cassegrain. Earlier on, I started off with Hyperstar. With the fast optics, you end up with a wider field, which is good, but I always felt I wasn't getting enough detail. But the new CMOS, the 183 color camera that I have, provides a higher, let's say, pixel resolution than my DLSR had, which I was using previously. You can see where I am in Marblehead isn't too bad, but it's not like what you guys have up in Cape Ann. I do have also with the Schmidt, not with this Rowe Ackerman Schmidt, I started using, I did use a light pollution filter. And just this year, I bought a filter drawer that allows me to use my narrowband filters, the hydrogen alpha and the oxygen 3 and the S2 filters for some of the nebula that I've been working with. So it's a nice little drawer that fits right between the lens and the camera, and I can even use my filters from the DLSR. So the first image that I'm going to show is many of these they called them, they came from Mount Wilson and Palomar. Mario, maybe you can fill me in on this. Why did they just combine plates to get this? Not sure, but this was circa 1950. It looks like early 1950, and it looks like it was a narrow band. But this is the Crab Nebula from those 2 observatories. So, and here's mine.
Yeah, not narrowband. They had blue sensitive emulsions and they had red sensitive emulsions, and they took 1 plate of each.
Okay. So you think that maybe one came from one observatory, one came from the other?
Yes.
Okay. So this is what I took back in November. 54 minutes for me. 54 minutes is a lot more number of images. This is without any filtering. This is straight to the camera. So the one thing about the CMOS camera that I have is that it's a one-shot color, is that it does have a nice red sensitivity to it. When I do use this camera with Galaxies, I actually use an IR cut filter with it. So this is the first time I've done the Crab Nebula in about 3-4 years. Now the important thing is that this one it exploded in the year 1054. So remember that number, because I'm going to get back to it later on. It's 6,500 light years away. Diameter is 11 light years. And supposedly the center is a neutron star spinning at 32 times per second. A little research that I found on it. The next one from this book that I was talking about is, they called it the Great Globular Cluster of Hercules. And here's my version of it. No need to expand on, Phil gave you the full detail of it. It is 22,000 light years away and 145 light years in diameter. I did notice there was a note that said you can actually, for the observers, nice dark sky, it can be seen with the naked eye as a fuzzy patch. This is a new version. I love doing the triangular galaxy. And if I were to show the same thing that Phil did, of how I've improved in the triangular galaxy over the years, because I actually got started with my astrophotography back in 2012. And I look at where I was then. Each year it just keeps improving. And without any narrow band filtering, I'm picking up a lot of the nebulosity here of these. I was real pleased with. There's nothing here that I accelerated. It just is. This is all natural.
Yeah, that's outstanding.
Thank you. It is 85 minutes. Now, 85 minutes on an f over 2.2 is the equivalent of, multiply that by at least 20. And that's the number of, if it was a f over 10 type of focal ratio. So I'm real pleased. I did this back in October. M31. You could see at least mine isn't as full as Phil's, but I really like the way the color. This is actually back in 2017. What I did learn is that for some reason I'm having trouble with Andromeda and even M42 with this CMOS camera, and it's just blowing out the center. And it's also too I can't get it in the field of view anymore. So I brought this one up because I wanted to show mine versus the Mount Wilson version of it. It makes me feel good that this is what we can do in 2017 or in these days, and this is what they had in 70 years ago, state of the art. I think this is my last one, which is Bode's Galaxy. Phil, you showed a lot of nice results. On this particular time that I did it this year, I couldn't get as much of the core, like showing like a little bit of the yellowish. I couldn't figure out why. It just must have been the way the skies were that night. But I do like the detail that I was able to bring out in it. Let's see, with that one, yeah, I'm not going to give the details because everybody knows these particular objects. Any questions? This once again is 73 minutes. Let's see, that's probably could be 140, 100 to 140. Depends on how long my exposure was. But I typically try, to get the detail, I can get anywhere from 100 to 150 images that I can start stacking. Because many times my images are only taking me 30 seconds, 35 seconds. Sometimes I've been able to stretch it out to 40 seconds.
It's amazing what you do, yeah.
Yeah, because when you look at each of these, well, this one was 52 minutes, but this one 85 minutes, I believe. I don't have the number of. This one was well over 100 images that I can stack up. So this one I redid this year back in the summer, and so this is the cocoon. I was really doing a lot of work in the Cygnus region. So the next few are going to be Cygnus region. I like this. I was just amazed because it's a much smaller object. I feel that it's very similar to the Trifid Nebula. as it's both it's a triple type of effect, both emissions and reflection, and you can see the dark lanes in there. It is 2,500 light years away, and I did find that the central star, that one right there, is only 100,000 years young, and they did say that it definitely has a stellar nursery of hundreds of young stars. But I really like the way this came out. You can see some of the nebula, the blue reflection really expanded out in this one. So I was pleased. Next one is Crescent Nebula, and in Cygnus also. This is 5,000 light years away. What I read was it's formed by a stellar wind from the Wolf-Rayet star. Bill, Mario, do you have any more information on that you can shed some light on that? Or
What was the question again?
well, it said that it's formed by a stellar wind from the Wolf-Rayet star.
Yeah, it's the shock
Yes.
wave. It's the shock wave of the wind hitting the surrounding material.
Right.
Right.
Now,
So-
the thing,
It's a Wolf-Rayet star. It's an old star with a strong stellar wind. And if you look at your photograph,
Mhm.
immediately to the right and to the left, you can
Mhm.
almost see the jets coming out of it.
yeah, like here.
In the
right?
north and south pole of the
Yeah.
star.
The only thing I'm missing is, and I'm going to try to get this next year, is I do not have any oxygen-3 data on this. But you can see how I started picking up some of the nebulosity in the surrounding area. And there's a nice blue nebulosity.
There's only 250 of these known in the Milky Way, as far as I can recall.
Okay,
It's a very rare type of star.
right. So you can see here, I've got the RGB color images that are stacked, and then I also had the hydrogen alpha that I did in the summer. Now, the next one, this is something that I think I've shown in the past, where I had the entire North American nebula and the Pelican. I even showed one year that I spliced them together. I did these on 2 separate, 2 months apart. Somehow the processing that evening, I just couldn't, get the colors the same. But I think you may have mentioned this, Bill, is that for the one on the right, not so much on the left, when I got enough on this particular one, I got depth at it. You see what I've got there? It created some depth in the
Yeah, it looks dimensional.
It looks dimensional. In fact, I showed this to a friend of mine, and I was told that it doesn't look like a pelican. It looks like an angel with the wings, just by the angle, like an angel body. But with the North America, you could see some depth in this one also, where you got Florida, Mexico, Midwest. So I kind of like those two. Yeah. So anyway, that's basically what I've been able to do recently with those two. Now, getting back to the Veil Nebula, what I wanted to show here is, being that I had the CMOS finer resolution, this is probably the best Eastern Veil Nebula that I've been able to get. It included both hydrogen alpha as well as oxygen 3. There's 41 minutes and 50 minutes of each. So there's probably around 60 or 70 images of each one. And what I also want to show is this is where the Eastern Veil sits in the entire veil. And you see that, and this one occurred, I think you mentioned earlier, my research showed that it's like between 10 and 20,000 years old. It occurred, and an M1 occurred 1,000 years ago. And the M1 here, right in this little corner, is scaled to the size of the Veil Nebula. So you can see how much it has expanded in 10,000 years versus 1,000 years.
That's cool.
So I thought that was a good exercise. Let's see. It is a remnant of a star that was 8 times more massive than our sun. When it occurred, scientists speculated that it would have been brighter than Venus and visible during the day. Let's see. The Veil Nebula is 25 times larger than the Crab, 6 times larger than the diameter of the Moon. And the thickness of each of these filaments in here is approximately 4 billion miles wide. And it's expanding at 1.5 kilometers per hour. So, and that was based on observations by Hubble of images taken between 1997 and 2015. They could actually see the movement during that almost 20-year period. So, next one was, I've done this over the years. You can see how I keep picking up more periphery of the nebulosity of the Eagle. This I did in the summer. There's approximately, not as many images as I would like, but I got a fair amount of hydrogen alpha. But I also wanted to see what was the resolution of my camera. And I blew up the center and just did a little bit more processing on it. And here's the, Hubble's, it's not the Hubble palette, it's just an hydrogen alpha and RGB. And I was able to get a fair amount of detail out of it. So I was kind of pleased with the pixel resolution of this camera. So next one is one of my favorite galaxies is the Sculptor Galaxy. I had done this a few years back. It's NGC 253, and it's a starburst galaxy undergoing a period of intense star formation, and it's 11 million light years away. It's low, and the amazing thing about this is that when I took these images, it's only 20 degrees above the horizon, 20 degrees altitude above the horizon, but it required that I take 104 subs to get my 43 minutes. And keep in mind, multiply that 43 minutes by 20, and then you'd have what the effective exposure total time is. So for me, total exposure time doesn't mean much. But I like on this one, you can see it's also called the silver dollar, silver coin. And I always like this because you can see somewhat of a depth, three-dimensional depth in this one. A friend of mine from my earlier version of this actually had this printed in Germany on I think it was some form of metal. And I'd love to do this on that fracture, try to do it on fracture. So that was sculpture. The next image is an old image from April of 2018, Markarian's chain. But I wanted to show you, this was a tile of 4 that I did with my RASA and my DLSR. And I was able to, with my new camera, work on this area to get a greater amount of detail. And the Markarian's chain is this group of galaxies, with the Messiers M84 and M86. And this is what it looks like blown up with the new camera. This is 60 minutes, so it's a roughly, let's see, 126 subs that I took with it. And not only did it have M84, M86, which are 52 million light years away, but also I picked up the 4402. So yeah, 4402, 4388, 4413. I think that's it. Let's see, 4425 and 4438. But what I also noticed is that with the greater amount of detail, I was able to pick up a lot of these extra little, very, very distant galaxies. I have no idea how far they're away, but I counted 15 extra galaxies within this one frame. Just to wrap it up, as far as images go, just like Marriott, on the 20th, this is a low-tech image. I took this with my DLSR camera on a simple tripod, sitting on our patio table, on our rear deck, because right below here are the power lines to my neighbor's house. There's no way I could get my telescope equipment on my rear wood deck, which would be very difficult to work with. So I just went low tech, and I was able to pick up Comet Neowise. What I'd like to finish off is that from this book, I want to read something what Fred Hoyle had said. and I found it interesting. It's at the end. It's called a personal view. I'm not going to read the whole chapter. I'll just read a little bit of it. It just says, it is likely that any astonishing new developments are lying in waiting for us. Is it possible that the cosmology of 500 years hence will extend as far beyond our present beliefs as our cosmology goes beyond that of Newton? It may surprise you to hear that I doubt whether this will be so. I am prepared to believe that there will be many advances in the detailed understanding of matters that still baffle us. Of the larger issues, I expect a considerable improvement in the theory of the expanding universe. Already, it is fairly clear that the theory of relativity is not an ideal tool for dealing with this problem. Continuous creation, I expect to play an important role in the theories of the future. Indeed, I expect that much will be learned about continuous creation, especially in its connection with atomic physics. By and large, I think that our present picture will turn out to bear an appreciable resemblance to the cosmologies of the future. If this should appear presumptuous to you, I think you should consider what I said earlier in the observable region of the universe. As you will remember, even with a perfect telescope, we could penetrate only about twice as far into space as the new telescope at Mount Palomar. This means that there are no new fields to be opened up like telescopes of the future, and at this point, of no small importance in our cosmology. That was written and published in 1950, 71 years ago. And look where we are.
Yeah.
Hubble and the upcoming, James Webb Telescope. We're identifying. Imagine if this guy could see what we know now. Exoplanets.
Yep.
All right. Well, thank you, Barry.
Oh, by the way, I like this one. I found this one today. Pointing in the wrong direction.
All right. Terrific. That was good. Just to keep it rolling, and we'll have a question and answer session at the end. Jeremy?
Yes.
Are you with us?
Can you hear me?
Yes, we can.
Okay.
You can share your screen and get going.
Okay, I will. Let's see here. Can you see this?
Yes.
All right.
It's not
Yeah,
on
that-
slideshow yet, but yeah.
I will start it from beginning. All right, here we go. Yeah, that Fred Hoyle, I saw some kind of documentary or something maybe last year about how he was kind of in favor of this stellar nucleosynthesis theory rather than the Big Bang, and I don't know, it was an interesting documentary. I hadn't heard of him before. So anyways, I will get going here. So I'll just tell you a little bit about me. Most of you probably got this spiel the last time around, but I'll make it quick. So I'm a relative newcomer to astrophotography and astronomy, really. I didn't really get into it until 2017 when I kind of stumbled upon this YouTube channel, Astro Backyard, and I just couldn't believe that type of imaging was possible with amateur equipment that you could do in your backyard. So that just really piqued my interest. And so I got binoculars in 2017, started kind of snooping around and learning some of the constellations. And then, eventually I got a telescope, and later that year, eyepieces and a mount that was not motorized, or I should say not computerized. So I eventually got an adapter to put my DSLR on the back of the telescope. And when I pointed it at Orion and I saw basically what you see in the bottom right there, I was just blown away. So I ended up really getting into astrophotography at that point. And then one thing led to another. I got a more serious mount. And then last year I got a dedicated astro camera, like a cooled CMOS full frame with filter wheels, the whole deal. Unfortunately, I've spent pretty much since I've got the setup debugging it. I've had one problem after another. Had to have my telescope collimated, my focuser repaired. I think I'm on my second camera and my second filter wheel, but I think I've got it finally straightened out. So unfortunately, I don't have any images from my new setup, but I just basically put together what I had over the past year since our last meeting, and just kind of picked a few of the best ones I happened to get. So my setup is pretty simple, I guess. It's just a 4-inch refractor. My mount is what they call a German equatorial, which tracks the sidereal rate and allows you to stay fixed on a star as the the apparent motion of the sky happens, and then there's a guide scope which helps make those small corrections, like when Phil was talking about doing that guiding manually. I'm lucky I didn't have to suffer through any of that. I just click the guide button, and the software tells the mount to just nudge this way and that way, and it's what makes this so accessible for people these days. So like I mentioned, I've done most of my work with the DSLR, and I just recently got this full frame CMOS camera and a 7-position filter wheel. By the way, the filters are really going to be the way that I can do a lot more imaging from home, because as you'll see, most of my pictures are taken, the bulk of the imaging is done like not at my house. I'm driving to Halibut or up north or out west. I'll show you where I image from. But the narrowband filters and a really sensitive CMOS camera are going to let me do a lot more from home. So that was a big reason in going that route. And I have a computer that controls everything and acquires the images, etc., and various other accessories. Oh, and by the way, that's my little observatory. It's not quite as fancy as Mario's, but I just made it out of some fencing attached to my existing fence next to my pool, and it actually, it works pretty well to shield the telescope from the wind and everything, and keep any prying eyes from seeing what's going on, because we live in kind of a somewhat busy area. So I live in Chelmsford. There's quite a bit of light pollution from Lowell, which is right next door. And so I end up driving to these other locations to do most of my quality imaging, I would say. I have relatives out in Ware, so I sometimes drive out there. Most often I'm going to Halibut, and where I see many of you guys. And then if not there, I will drive up to the Pemi overlook right off the Kankanamegus Highway, just outside of Lincoln, New Hampshire, which is a wonderful site. For only being 2 hours from home, it is really quite nice. So I highly recommend it. So here's my first image. I don't have the type of telescope that would normally be great for galaxies, at least most galaxies, because my setup is really more wide field. But I was still pretty happy with this. This is M51, the Whirlpool Galaxy. I'll just read a little bit here. It's basically a grand spiral galaxy. Such striking arms are a hallmark of so-called grand design. In M51, these arms serve an important purpose. They are star formation factories, compressing hydrogen gas and creating clusters of new stars. Some astronomers think that the Whirlpool's arms are particularly prominent because of the effects of a close encounter with NGC 5195, the small yellowish galaxy at the outermost tip of one of the arms. The compact galaxy appears to be tugging on the arm, the tidal forces from which trigger new star formation. Hubble shows that NGC 5195 is passing behind M51. The small galaxy has been gliding past the Whirlpool for hundreds of millions of years. The red represents infrared light as well as hydrogen within the giant star-forming regions. The blue color can be attributed to hot young stars, while the yellow color is from older stars. M51 was discovered by Charles Messier in 1773, and M51 is 31 million light years from Earth in the constellation Canes Venatici. And I should be able to zoom in here. So I don't, I don't have a lot of zoom with the telescope, but I have decent enough resolution where I can still pick out some pretty good detail. And this is 6 hours of exposure time from halibut point, and 6 hours of exposure time just to get some of that that red HA region where there's star forming going on, and I just add that in. It's not really, it's only representing a small part of the of what you see there, but it does give a little bit extra detail. So I will go to the next one. This is an object I hadn't really heard of, and I forget what led me to it, but I kind of set it up as a target, not quite knowing what to expect. But I was up at the Pemi Overlook where it was very dark, so I figured it would be a great chance to see what it is. So this beautiful blushing nebula is unique amongst its counterparts. While many of the nebulae visible in the night sky are emission nebulae, clouds of dust and gas that are hot enough to emit their own radiation and light. Caldwell 4, otherwise known as the Iris Nebula or NGC 7023, is a reflection nebula. This means that its color comes from the scattered light of its central star, which lies nestled in the abundant star fields of the constellation Cepheus. Located some 1,400 light years away from Earth, the Iris Nebula's glowing gaseous petals stretch roughly 6 light years across. This nebula is of particular interest to scientists because of its colors. Reflection nebulae glow because they are made up of extremely tiny particles of solid matter up to 10 or even 100 times smaller than dust particles on Earth. These particles diffuse the light around them, giving the nebula a second-hand glow that's typically bluish. While the Iris Nebula appears predominantly blue, it includes large filaments of deep red, indicating the presence of an unknown chemical compound, likely based on hydrocarbons. So I'll zoom in here so you can see a little bit more of the detail there in the core. And I don't know, I just really like this object. I'm liking more and more to see the dark nebula, which are basically clouds that are blocking the light of the stars behind them. So I'm finding those types of targets more interesting as I go along. So this was only 3.5 hours, just with the DSLR, no filters, and this was from the Pemi Overlook. And then I did add some HA from home, but it doesn't add too much. It gives a little bit more of the red tinge there outside the core. And then, of course, this is Comet Neowise. I really kind of hit the jackpot on. I went out for 3 nights out to Halibut Point, and each night I was able to get some really great shots. This was, I think, the last night I went out, and it's only 7 minutes of exposures. They were 60-second subs stacked together. If you go beyond a few minutes, you start to lose some of the detail in the core, and the stars will start to trail a bit more. Of course, I was tracking with this one, so I wouldn't get the star trails. But yeah, so also known as C2020 F3, it's a long period comet with near parabolic orbit discovered on March 27th, 2020 by astronomers during the NEOWISE mission of the Wide Field Infrared Survey Explorer space telescope. At that time, it was an 18th magnitude object located 2 astronomical units away from the sun and 1.7 astronomical units away from Earth. WISE performed an all-sky astronomical survey with images in these various wavelengths over 10 months using its telescope in its Earth orbit. And basically, NEOWISE was the mission was supposed to be searching for near Earth objects, and it ended up stumbling across this comet, which turned out to be, one of the, I guess I would say it's one of the great comets now, because it was so visually apparent. I mean, when I first got to when I first went to Halibut that first night, I could see it clearly up in the sky, and I was lugging my gear out to the point, and it was just there, hanging above the horizon. So it was really awesome. And yeah, there's not too much. I mean, I can zoom in a little bit, but it's not a very detailed object, but you can see the core and the dust tail and the ion tail, and Mario explained that already. So this is the Triangulum Galaxy M33. Barry already talked about this one as well. This is it's about half the size of the Milky Way. It's the third largest member of our local group of galaxies, following the Andromeda Galaxy and the Milky Way. Hubble's observations reveal that the Triangulum Galaxy star formation rate is 10 times higher than the average found in the Andromeda Galaxy, previously surveyed by Hubble in similar detail. Also shown is NGC 604. It's the largest star-forming region in M33 and one of the largest stellar nurseries in the entire local group. Only slightly farther away from us than Andromeda, about 3 million light years from Earth, M33 is a suspected gravitational companion to Andromeda, and both galaxies are moving toward our own. M33 could become a third party involved in the impending collision between Andromeda and the Milky Way galaxies more than 4 billion years from now. So NGC 604, if we zoom in, it's this one right here. I'm not sure if you can see that, my pointer, but it's right there in the center. It's that reddish, purplish hydrogen alpha region. So this is only about 4 hours of exposures that I got from, see, 3 hours I got out in Ware, and then I got 1 hour up off the Kangamegas on the Pemi Overlook there. So that's 4 hours total. I hope to give this some more time and get more detail, and just keep working on it as it comes back up in the sky. So I think I only have one more, and I'm not sure if this might. Well, anyways, this is Andromeda, as you can probably tell, and I guess we all pretty much know about Andromeda, so I don't need to tell you. But this is 4 hours, I guess. So let me think here. Yeah. Oh, no, that doesn't sound right. I must have more than 4 hours at that point. I could be wrong. I think it might be more like 8 hours. But anyways, it's been something I've been taking each year and adding to each year, adding more data to it. And this is just my latest stack of all my images. So I will keep working on it. I will probably start new with my new camera, because it's a full frame size sensor, so I should be able to get the entire thing in the frame and not really be cutting off anything, where here I am losing a bit. So let me see if that's, no, I have one more. All right, so this is my last one. This is the Pleiades. This is 4 hours and 40 minutes from Halibut Point. The Pleiades are a group of more than 800 stars located about 410 light years from Earth in the constellation Taurus. Most sky watchers are familiar with the assembly, which looks something like a smaller, hazier version of the Big Dipper in the night sky. And actually, when I was a kid, it was one of the first things that I would recognize when I looked up in the sky. Every fall, in winter, I would look up and I'd be able to find it. And at the time, I thought it was the Little Dipper. I didn't really know any better, but it was interesting to, just rediscover it so many years later. Also known as the Seven Sisters and M45, the object derives its English name from the Greek legend. The Pleiades are the 7 daughters of the Titan god Atlas and the ocean nymph Pleione. During an ancient war, Atlas rebelled against Zeus. the king of the gods, who sentenced his foe to forever hold up the heavens on his shoulders. The sisters were so sad that Zeus allowed them a place in the sky in order to be close to their father. The Pleiades are an example of an open star cluster, a group of stars that were all born around the same time from a gigantic cloud of gas and dust. The brightest stars in the formation glow a hot blue and formed within the last 100 million years. They are extremely luminous and will burn out quickly with lifespans of only a few 100 million years, much shorter than the billions of years our sun will enjoy. And so I think that's it.
All right, terrific. Thank you, Jeremy.
No problem.
All right, and finally, John, are you still with us? John, you're on mute, so you need to click that little mute thing in the lower left-hand corner. There you go.
Well, okay, I'm going to open the PowerPoint,
Okay.
and it's open. So where do I do the share? I got to go
The
back.
bottom of your screen, there's a green button,
Share the screen.
and then you have to pick what you want to share and just pick the PowerPoint.
This is here. Why doesn't it come up? Oh, share it. I got to click it. There we go. All righty. Let's see. I got to do slideshow, right?
That's right. And then from beginning, and you're all set.
Slideshow. All right, it's from the beginning. Okay. This is this is going to be all Southern Hemisphere. I call goodies. I do a lot in the Southern Hemisphere because they have more telescopes down there that I can use as opposed to the 3 in Spain and the 8 or 9 in New Mexico. So I end up going there. The only drawback to going to Australia is you got to get up early in the morning to get on. So I'm a late night person. It's pretty hard for me. But anyway, I'm going to go through some of the ones you've probably seen a few of these before, but let's go through them here. Oops. Can I back up here? There we go. This is a couple of reflection nebula here at the top right. It's NGC 6726 and 7 in Corona Australis. And this globular cluster up here is NGC 6723. It's actually right across the borderline in Sagittarius. So the line goes somewhere right along here. Now, the interesting thing about this is it contains a lot of interesting stuff. The globular cluster is 30,000 light years away. And these two reflection nebulae up here, the ones I'm talking about, are only 426 light years away. And these two together are called the Anteater Nebula. I can't tell you why. Maybe it looks like an anteater. I don't know. There's also a double star in here, and I'll show you a better picture of that in the next image. And there is this very nice dark lane here, looks like a boomerang. It's called Bernays 157. So let me go to the next slide. Now, that previous slide was taken with a 12-inch plane wave, and this is taken with a 17-inch plane wave, and it shows you a little more detail. This is actually a reflection nebulae down here. It's both an emission. No, it's actually, this is IC 4812. It's a reflection nebula, and it also contains a double star. And I went to a bigger telescope to show you. You can see the two diffraction spikes from the double stars in this image here. The only other thing of note in here is this little tadpole shaped thing in here is actually a protostar. It's formations of a new star taking place. I can't tell you anything else more about this. I kind of like it because it's got a little bit of everything in it. Let's see, next image. This is the small Magellanic Cloud. And up in the right-hand corner, you'll see this image up here. This is 47 Tucanae, which is the second largest globular cluster, right after Omega Centauri. And this thing is it's pretty good size. I was surprised I could get it in the same field of view. I took this with a 90mm Takahashi wide field, and it's got a lot of objects. It's the cloud is considered as an irregular dwarf galaxy, and it's in the constellation Tucana, which is where 47 Tucana, and Hydrus, which is over here. And it's big. It's 5 degrees 20 minutes by 3 degrees and 5 minutes. It's 3,500 light years wide, this whole area across here. And it contains all kinds of little objects. There, right up above here, which I couldn't get in the picture, is a globular cluster called NGC 392, I think. It's about half the size of the M13, so it's not great big, but it's nothing like this one. And
That's the small Magellanic Cloud.
this is, yes, yeah. And in here, there's a whole bunch of star clusters. I can name them for you if you want, but there's NGC 395, 371. There's a couple more down here, 346, 330. It's quite a ways away. It's 190,000 light years from Earth, so it's not that close. And but it's an interesting object, and I wanted to show you. Go on to the next slide, which will focus on 47 Tucanae. And this is the globular cluster in Tucana. It's 16,000 light years from Earth. It's about 120 light years wide, and it's got a visual apparent magnitude of 4.9. It's one of the few globular clusters that you can see with the naked eye. It's not as big as Omega Centauri, but for comparisons, M13 has a diameter of 20 arc minutes and is only visible in dark skies, while 47 Tucanae is a 30 arc minute diameter. Contains millions of stars, and I took this with a 17-inch plane wave, and it's about 12-hour exposure. And this is kind of nice because you can do a pretty good resolution of the center. And it does contain some interesting, there's a red star over here and a couple blue ones in there. I can't tell you anything more about what else is in there. It's I don't think it's a metal rich globular cluster, but let's see what's next here. I'm going to go through these fairly fast. That's just another image of the same thing. It's not as nice as the one before it, so let's get out of there. This is the Eta Carina Nebula in Carina. It's 8,000 light years from Earth. It's 400 light years across, and I don't even have all of it in here. It's got nebulosity that goes way up off most of it off of the top right side of the image. It's a very large emission nebula. And this is where the Carina star is right down here in this little location down here. It's 3 degrees by 2.5 degrees. The Orion Nebula is only 0.9 degrees in diameter, so it shows you some idea how big this thing is. And its luminosity is about 4 times that of the sun. And there's a supermassive black hole here in the center that's 100 to 150 times that of our sun. And of course, the red color in here is mostly due to hydrogen alpha. And this again was taken with the 90-inch wide field refractor, Takahashi Sky 90 wide field. And this is about 11.5 hours of exposure. Now I'm going to show you, I did this before in one of the other presentations, and there's a whole bunch of other objects in there, all kinds of star clusters in here. I'm not going to begin to point them out. There's some other nice, in all of this, some nice little nebulae, but I'm only going to concentrate on one. And it's the, and get the next image. This is I never knew about this until I did some more looking around. This is called the Statue of Liberty Nebula. And this is just hydrogen alpha. And you can see here's the statue right here with the torch up on the top. And it's interesting because it's a bright emission nebula, and it's 100 light years across, and is about 9,000 light years away. There is a prolific star formation occurring, and because of this, there are many hot, young, massive stars which produce large amounts of UV ionizing radiation. And which ionize the nebula. Also, the stellar winds from these massive stars cause some of the looping filaments that you see up here at the top, and this kind of thing. And the UV radiation energizes the H alpha, the O3, and sulfur 2, making this a really colorful target if you want to go after it. It's going to have all kinds of blues and greens and stuff in it. But I knew nothing about that, and I just sort of stumbled across it when I was looking through the catalog trying to find something to do other than what I'd done before.
Great image. Where is this?
It's in Ada Carina. It's in the if you I can go back. Let's see. Oops, that's the wrong way. It's way the heck up over in here somewhere. I'm sorry, I can point up over. It's over here off the screen somewhere. And I as I said, I sort of went looking for it, and I was looking for something else to image in there, and I really couldn't find anything that I hadn't done before. And so I tried that one, and that's not a very long exposure of the hydrogen alpha, but it's there's a lot of stuff in it. You can get it without a lot of time. And I've only got one more image, so we'll be done here quickly. Let's see, I got to go this way. This is
more images.
The Tarantula Nebula. It's in the constellation Dorado. This is in the Large Magellanic Cloud. They're actually not that far apart, I don't think, when you look at them. If you could get them all in the same place, they're both big. This one's pretty far away. This is 163,000 light years from Earth, and it has about 300 light year apparent diameter and a magnitude of 5.4. This right here is actually the Tarantula Nebula. Now there are some other things in it. Right up here is what I want to say. Oh, it's 1987A supernovas right up here in this little corner up here, right up in there. And there are all kinds of things over here. This is a 22-hour exposure with the 20-inch. It's a composite of a couple images with the 20-inch corrected Dahl-Kirkham plane wave out of the Siding Springs. And there's a couple other little things in here you might want to look at if you get a chance. Here is what the hell is it called? I can't remember the name of it. I know what it is. This is the Seahorse Nebula right here. And there's another little nebula right in here. It's an emission nebula that just happens to be called, it's NGC 2074. And this luminosity of, well, this thing has about a core, I'd say somewhere around 500 to 1 million suns, a core between that many suns in here. It's that bright, and it's 40 arc minute by 25 arc minutes. Just this little part of the Tarantula Nebula, and the luminosity is so great that it was close to Earth as the Orion Nebula would cast shadows like the moon. Just an amazing object. And I had one of these before, but it was mostly just this area here. And this is actually a composite of 2 pictures. And I added a lot more time to it, to what I had before. So this actually represents a little over 22 hours of exposure.
Looks more like the exploded sheep nebula.
Yeah, it's a pretty object, and then and actually, if you could do a wide field of this whole thing, you could see tons of stuff over here, all over the place. It's quite quite a nice object, and I enjoyed doing it. So it's
Hey, John?
Yeah.
Do you know what all those little bullseye looking things are, like down at 4 o'clock here, or at 7 o'clock? Those kind of little spots with they almost look like little.
Oh, in red over by the side?
here.
Well, that's the biggest one, but right above that, there's a bunch of little ones.
No, I haven't really.
All right.
I haven't actually found anybody that's. I haven't found an image that has everything labeled on it. So I did looked up these little these two little objects over here and the supernova up here. I don't know what they all are. I looked around the other day and I couldn't find anything to give you.
They're all H alpha objects.
Yeah,
with
yeah,
new
yeah,
star formation.
Yeah, lots going on. It's an interesting object. I got blown away with it the first time I took it. It's pretty far away. It's 163,000 light years away. Not real close, but it was fun doing. But that's what I have.
All right, thank you, John. And let me say for everybody here, I'm sure, thank you so much. You guys were brilliant. And thank you for your time and your talents, donating them to us tonight. How about a round of applause for our photographers, everyone? Yay!
Thank you, Michael, for always putting it together. Great agenda.
All right.
Thank you.
Okay, John, stop sharing.
Where do I do that?
Top of the screen.
Top of the screen, John.
Oh, share them all again.
Right here?
It'll say stop sharing.
Oh, here. Stop share.
There you go.
Happy to do that.
There you go. And now we can open it up to questions and comments, and the jargon lamp is lit.
Okay, I just want to say 47 Tucanae, if no one's ever seen it visually, is the single best object in the sky. I've seen it a few times now. It's now my favorite object. I wish I lived in the Southern Hemisphere.
Yeah,
If you ever get to look through it through a telescope, it will blow you away.
yeah.
I
I was
heard
amazed.
Eta Carina is quite an amazing object, even visually, right?
Yeah, it's you don't have to image that very long to get some nice color in it, but it's just, the more you go, the more detail you're going to get, the more wisp and all this kind of stuff. So it's a nice one.
Does anybody have any questions for any of our photographers?
Well, I do have one comment to add. I'd never heard of the Statue of Liberty Nebula, and a lot of people that I know never had either. A friend of mine moved to Texas last year and just took an image of it. Is there any way I could share it?
Yeah, sure. Hang on a second. I have to upgrade you. All right, now you can share your screen, Jim.
It says it's still disabled. Okay.
Hang on. How about now? You're a co-host.
There we go. Okay. This should be it right here.
So he did that in narrowband Hubble power.
Hey, Bill, do you figure those are magnetic lines there, those arcs?
No, those are the solar wind pushing that stuff around.
Yeah, I was just intrigued by the 3 or 4 separate loops.
That's what I read about it.
You mean this structure over here, right?
Yeah.
They
Yeah,
do look loopy.
And here's the torch, I guess, and the head of the Liberty.
Thank you for that biting insight there, Bill.
Is that
Looks like
star?
it's expanding bubbles.
Is that star we see the source of those solar winds? The
Yeah,
star
they're-
that sort of looks like it's in the center there.
Embedded in here?
Yeah, hot stars. Yeah.
Probably.
Yeah, beautiful.
Wow.
Yeah, he just started imaging this year, but he's been doing all planetary until now.
Where did he do this?
A little south of Houston on the Gulf Coast.
He could see that from the Gulf Coast?
Yep.
Really?
It
Oh,
was
good.
low on the horizon, but he got it.
Yeah.
That means I should be able to get it from Florida.
Yeah.
Give it a shot.
Carina is, I guess, is visible from that far north, but no way you're going to get the small Magellanic
No,
Cloud or the large Magellanic Cloud.
that's definitely below the horizon.
Below the horizon.
You have to be in the southern hemisphere.
Orion is almost at the zenith here.
Yeah,
Which is
47
kind of a-
Tucanae is right next to the South Pole,
Yeah.
which is too bad.
Yeah.
Everybody, by the way, this is our friend Alan Winter, who we haven't seen in a couple of years. He lives in Austin. You remember Alan?
Oh, yeah.
I miss coming to these GAAC meetings, and this is how spacey I am. I work nights and sleep days, and I forgot that you guys are an hour ahead of me, so I missed everything except John's last few.
It's all right.
really wish-
It's recorded.
It is?
Yeah.
Oh, good. Okay, so I won't miss it. But anyway, hi. Wish I could be there in person. The skies are darker here, guys, in Texas. Political climate's darker also, but it's
But we don't discuss such things in GAC.
exactly. It's quite a place here.
Quite a place.
The first international, U.S. international dark sky site or city is right next door to me, Dripping Springs. I can drive there in 15, 20 minutes.
Wonderful.
All right, well, I'm very, very uncomfortable with extended moments of silence, so I'm going to let everybody go.
All right.
Thanks everyone for coming, and listen, you five guys, thank you again. We really
Well,
appreciate it.
Thanks, everybody.
Welcome. Thanks, Michael.
Hey, William.
Michael.
Hello, Dr. Amato.
Blew me away.
Hello, Dick Lutzi.
I'm leaving.
All right, everybody.
Bye-bye.
Hello, Phil.
Good night.
Evans. How
So
about
how you doing there, Fritz and Alan?
Doing pretty good, Mike. How about you?
Doing all right. Alan, this is my oldest friend in the world. Fritz.
your oldest friend in the world?
Yeah,
I'm
pretty
pretty
much.
old.
Nice to meet you, Fritz.
How's it going, bud?
Hey, who's Patty Deneen?
That would be my sister.
I didn't know your sister was into astronomy.
Well, she likes looking at the pretty pictures.
Yeah, so do I.
So do I.
So how do I get to the recorded bit? Where is that?
We're on the GAAC Facebook page right now.
Yep.
And I also have the recording, which I'm going to put on Bill Waller's and my astronomy journal, the Galactic Inquirer.
Okay. If I can't
That's
find
at
it, I'll look for it.
galacticinquirer.org.
Okay, cool. If
And
I
that'll
can-
be in the next couple of days, but it should be live on Facebook now.
Okay, good.
All right.
Thanks.
And
All right.
Fritz, fish too. I'm impressed with the background. You're really nailing it there.
Anything worth doing is worth overdoing.
It's worth doing twice anyway. Yeah.
More is better.
All right, guys.
All right, good night, guys.
All right, you guys are both on our permanent invite list, so you'll be hearing from us.
Awesome. Thanks, Mike.
Thank you very much, Mike.
Nice
Take care.
meet you,
Great to
Fritz.
see you both. Thanks a lot.
Good night.
Bye-bye.
Bye-bye.